Howdy, folks. Welcome back to another episode of Tech with Travis. Today, we will discuss evaluating AI development. We will also pass the discussion to the Google Podcast host from Notebook LLM to cover these important technology enhancements. AI advancement relies on two critical pillars, Evals and Model Context Protocol, MCP. Evals, or evaluations, provide comprehensive testing frameworks measuring accuracy, safety, and performance through automated benchmarks and human assessment loops. MCP enables secure interaction between AI models and external tools, streamlining development while maintaining safety guardrails. Together, they're transforming how AI systems are deployed in healthcare, finance, and other sectors, ensuring both innovation and accountability through structured evaluation and seamless integration capabilities. Now let's hear what our podcast hosts think of these topics.
Welcome to the deep dive. It's great to have you with us today. We're jumping into a really critical and honestly fast-moving part of artificial intelligence. We're not just talking about, the latest tech buzzwords. We're really going deep into how AI is being built so that it's, fundamentally trustworthy, but also, and this is key, actually useful in the real world. Okay, let's unpack this. Today, our deep dive is focusing on two pillars, maybe unsung heroes, that are kind of quietly shaping how fast and, importantly, how safely AI goes from the research lab into your life. We're talking about Evals evaluation methods, but way more than just tests and MCP, that's the Model Context Protocol. Think of it like a universal translator that lets AI connect properly with everything around it. You might actually be surprised how much these two somewhat technical-sounding concepts really hold the key to where AI is heading.
That's exactly right. And understanding Evals and MCP, even just getting a solid handle on them, isn't just for academics. It really dictates, quite precisely, how safely and, maybe more importantly, how quickly AI can go from being a cool idea in the lab to something that actually impacts the world. I mean, the pace of AI right now is just unprecedented, isn't it?
Yeah.
And that pace absolutely demands this solid foundation, trustworthiness, and actual utility. Without those, even the smartest AI models risk just not reaching their potential.
That's a really crucial point. So our mission today for you listening is to pull out the most important bits of knowledge, maybe some surprising facts too, about Evals and MCP. We want to show you how these aren't just, jargon for developers. They're absolutely essential for the future of AI. By the end of this, you'll get why these two are so central to AI we can trust and actually use. It'll help you make sense of the whole AI landscape. All right, so with that set up, let's peel back the first layer, the trust foundation. Evals, expert. How do we even start defining what these are?
Okay, so Evals. At their core, they're basically structured procedures, right? Specifically designed to measure, every relevant dimension of how an AI model performs and behaves. But the key thing to remember is they are way more than just a simple pass-fail test. That's really important.
Okay, so not just a checkmark exercise.
Exactly. Think of it less like a pop quiz, more like a really thorough, ongoing diagnostic process, like a comprehensive health checkup, maybe. Blood tests, scans, the whole deal. And the way we do it now, modern evaluation frameworks, they're pretty sophisticated. They mix automated benchmarks. Those give us the hard numbers with continuous monitoring, which watches how things perform in real time, and critically, human assessment loops.
Human assessment.
Yeah, bringing in actual human judgment for the nuances, the things algorithms might miss. This whole multifaceted thing gives us a really holistic view of what an AI can do, and just as importantly, what its limits are.
That distinction is vital. Far more than pass or fail. So when you say measuring every relevant dimension, what does that actually look like? How do you get objective, repeatable measurements for something as complex as AI?
Right. Good question. Achieving that objective, repeatable measurement relies on a few key components working together. First up, you've got standard test suites. These are like meticulously built sets of tests. They quantify the critical stuff. Things like accuracy, obviously, how often does it get it right? But it goes so much deeper.
Okay, give me an example. Accuracy seems straightforward, but what else?
Sure. So imagine a medical AI, right? Diagnosing diseases from scans. Maybe it's 99% accurate overall.
Sounds great.
Yeah.
Sounds amazing.
But what if that 1% error always happens with, say, older patients or a specific ethnic group? That's where fairness evaluation comes in. We use specific tests to check if the AI's decisions are inadvertently biased against certain groups. Think about loan approvals. You absolutely cannot have an AI discriminating based on ethnicity or gender. The impact is just too huge. So we test for that specifically.
Got it. So accuracy isn't enough if it's not fair accuracy.
Precisely. Then there's robustness. Think about a self-driving car. You don't want a tiny bit of dirt on a sign making it swerve, right?
Definitely not.
That's robustness. Can it handle slight variations, noise, real-world messiness in the data? We test blurry images, different lighting, stuff that's partially hidden. It needs to cope. Then, privacy leakage. This is a big one. These models train on massive data sets, sometimes sensitive stuff. We have to check the model isn't accidentally spitting out private user information it learned. Huge for trust and security.
Yeah, you hear horror stories about that possibility.
Exactly. And then there's latency. How fast does it respond? Critical for real-time stuff like, well, self-driving cars again or surgical robots. Milliseconds matter. You can't have lag. And increasingly energy use, especially with these enormous models. Is it sustainable? A super accurate model that burns a ridiculous amount of power isn't really a net positive, is it?
That's a really good point, often overlooked.
Right. So each of these dimensions, accuracy, fairness, robustness, privacy, latency, energy, they're all crucial. A model might ace accuracy but fail badly somewhere else, making it useless or even dangerous. These aren't just nice-to-haves. They're fundamental requirements.
Okay, so that's the standard testing. What else? You mentioned other things.
Yeah, beyond those standard suites, we do adversarial red team exercises. This is where it gets really interesting. It's kind of like deliberately trying to break the AI.
Like ethical hacking, but for AI behavior.
Exactly like that. Red teaming is proactive, often really creative. Experts intentionally craft tricky inputs or prompts designed to make the model misbehave in unexpected ways. They're looking for harmful outputs, subtle biases, vulnerabilities that simple accuracy scores would just completely miss. We've seen red teams get seemingly harmless AIs to generate dangerous instructions or create really convincing fake news.
Wow.
The whole point is find those failure modes before deployment, turn weaknesses into learning opportunities, make the system stronger.
Proactive defense. Makes
Yeah.
sense. What else?
And then there's long-term drift tracking. This is vital because the real world changes, right? Data isn't static.
Right, trends shift, new info comes out.
Exactly. So an AI model's performance can decay over time if the data it sees starts looking different from its training data. Imagine a fashion trend predictor trained on 2020 data, not much used in 2024, eh?
Ha, definitely not.
Drift tracking constantly monitors the model's outputs and the incoming data to spot these shifts. If it detects significant drift, it flags that the model might need retraining or tweaking to stay reliable and useful. Without it, a model that was great on day one could slowly become useless, or worse, harmful.
That whole picture, standard tests, red teaming, drift tracking, paints a much more complex view of evaluation than just, is it right? It's about reliable, fair, sustainable performance under pressure. So how does all this technical stuff translate into, the real world? Responsible deployment, compliance. The stakes feel higher now.
They absolutely are higher. And Evals are indispensable for that safety and governance alignment, especially in those high-stakes areas. Medicine, finance, critical infrastructure, things that really affect people's lives.
Let's talk regulatory compliance. We're seeing this globally. The EU AI Act, the NIST AI Risk Management Framework here in the US. These kinds of regulations increasingly require documented proof, evaluation evidence, before you can deploy an AI, especially in sensitive fields.
They need to show your work, basically.
Pretty much. For AI in medicine, diagnosing diseases, or in finance, deciding on loans or managing power grids, you need proof it's been thoroughly checked. Accuracy, bias, robustness, it's becoming a legal and ethical must-have, not just good practice. Evals provide that documented, auditable trail.
Okay, so it's becoming baked into the law. What about how companies actually build this stuff?
Well, many forward-thinking organizations are now building Evals right into their automated continuous integration, or CI pipelines.
CI pipelines. Those are the automated systems developers use to build and test software constantly.
Right.
Exactly. So by putting Evals in there, every time a developer commits new code, even for a small update or an experiment, the new AI model version automatically goes through a battery of these tough tests. And here's the kicker. If that new version fails, if it crosses some predefined risk threshold, maybe bias increases slightly or latency spikes, the pipeline automatically blocks it from being deployed.
Ah, an automated safety net.
Precisely. It stops potentially problematic models from ever reaching users. It builds safety right into the workflow, not as an afterthought.
That sounds like a really robust system. But, AI is moving so incredibly fast. These frontier models, the really big, powerful ones. How do Evals even keep up? Is it a constant chase?
That's a really sharp question.
Yeah.
And yeah, it's a huge challenge, closing what's called the evaluation gap for these frontier models. The reality is our traditional metrics, they're still essential, but they can be. Well, incomplete for models working in really open-ended domains.
Like what kind of domains?
Think about models that write complex software code from just a text prompt, or help scientists brainstorm new hypotheses, or create completely new music or art. The sheer complexity, the novelty, the subjectivity. A simple accuracy score just doesn't capture the whole picture, does it? How do you score the accuracy of a novel scientific idea? It's not yes-no.
Right, it's much fuzzier. So what's the solution?
Well, the field is investing heavily in new evaluation approaches. One big area is large-scale crowdsourced judging.
Using lots of people.
Exactly.
Yeah.
Leveraging the nuance and common sense of many human evaluators. When an automated test can't quite grasp the quality, creativity, or safety of what an AI generates, humans provide that essential feedback. Assessing factual accuracy and open answers, coherence, spotting subtle bias, it adds a rich qualitative layer. Another approach is synthetic scenario generation. This means creating challenging but controlled test environments. We simulate complex situations, maybe with ambiguity or ethical twists, to see how the AI responds under pressure.
Like a flight simulator for AI.
Kind of. Or testing a self-driving AI in a virtual city with unexpected events. Or hitting it with millions of slightly weird inputs to test robustness. It lets us probe for weaknesses safely. And, really importantly, interpretability-driven tests. This is about moving beyond just what the AI decides, to understanding why.
Opening the black box.
Exactly. If we can see how an AI reached a decision, which inputs mattered, we can better diagnose errors or biases. That's crucial for improving safety and building trust, especially in complex applications. We need that window into its reasoning. And what's really helping pull all this together are open specification formats, like YAML-based eval cards. These are standardized ways to describe evaluation tasks, data, expected outcomes.
Standardized descriptions. Why is that important?
Because it lets the whole community, researchers, different companies, safety auditors, share new tasks and benchmarks easily. It fosters collaboration. Think about software testing, and traditional engineering tests are shared, scrutinized, improved collectively. This brings that same collaborative power to AI evaluation, speeding up safety research. There's a great quote from the NIST Working Group report that sums it up perfectly. You cannot manage what you do not measure. Comprehensive evaluation is the single most effective lever we have for raising the reliability ceiling of AI systems.
You cannot manage what you do not measure.
Wow. That really nails it, doesn't it? Evals aren't just technical checks. They're the actual path to trust and quality. Absolutely paramount for understanding AI's future. Okay, so evals make AI responsible and reliable. Let's pivot then. If evals prove a model works, what makes it truly useful? How does it go from being this trustworthy engine to, a car that actually drives somewhere useful? That's a perfect analogy for the shift. If evals build trust, then MCP Model Context Protocol delivers the utility. I often think of MCP as the operating fabric, the connective tissue for AI that needs to be connected and scalable. Its whole job is to make AI models genuinely useful by letting them talk seamlessly with external data, with all sorts of tools, even with other AIs.
How does it do that?
Through a clear, standardized, and importantly, extensible context specification. So while evals prove the model can do the job reliably, MCP lets it actually do the job by interacting with the world in a structured, efficient, and auditable way. It's like the difference between having, say, an incredibly powerful calculator on its own, and having one that can instantly pull livestock market data, execute a trade based on that data, and then log the whole transaction perfectly. MCP connects the raw intelligence to real-world action.
That operating fabric idea really clicks. Can you give us some practical, maybe real-world examples of how MCP enables this seamless integration? What does it mean for developers day to day?
Absolutely. One of the biggest wins, especially for businesses, is seamless integration with enterprise resources. Think about how things used to be. If you wanted an AI to access, say, your company's customer database, or use a specific internal tool, maybe send an email, update a calendar, check, inventory developers had to write custom code, these bespoke wrappers, for every single interaction.
Like building a unique adapter plug every time.
Exactly. It was incredibly time-consuming, prone to errors, and integrating a new AI feature could take weeks, even months, just writing that glue code. With MCP, instead of writing unique wrappers, developers just defined a structured function schema for their tools, databases, services, whatever. This schema is like a standardized blueprint. Here's what the tool does, what inputs it needs, what outputs it gives.
Okay, universal description.
Precisely. And the magic is, any AI model that understands MCP can discover and understand this schema at runtime. The AI doesn't need custom code for each tool. It learns dynamically how to use it from the schema, like a universal language for tools.
That sounds like it would speed things up massively.
Oh, hugely. And it cuts down on recoding every time a tool changes or a new one comes along. Plus, the protocol itself handles a lot of the tricky underlying stuff automatically. Things that used to cause developers massive headaches.
Like what kind of stuff?
Things like authentication, making sure the AI has permission, handling secure tokens. It manages rate limits, stopping the AI from accidentally overwhelming a service. It does schema validation, checking data formats, match expectations, catching errors early. It even handles version negotiation, so different tool versions can work together smoothly.
Wow. Okay. So it handles all that background complexity.
Exactly.
Yeah.
It's a massive game changer. Developers can focus on the interesting part, the high-level logic and problem solving, instead of getting bogged down in the tedious, error-prone plumbing.
That definitely sounds like a huge efficiency boost, stripping away all that custom glue code. What are the tangible benefits for businesses? How does it really hit the bottom line in terms of development time and ongoing costs?
The impact is really significant. Right across the software lifecycle, you see clear, quantifiable business benefits. Let's look at time to production. We're seeing reports from early adopters, companies using MCP-compatible systems, showing that projects, especially complex AI integrations, are getting from prototype to production. Well, in about 2/3 of the time it took before.
A third faster. That's huge.
It is. And it's directly because these reusable standard tool definitions from MCP replace all that custom glue code. Developers aren't constantly reinventing the wheel. That means faster iterations, getting new AI features to market quicker, which is a big competitive edge.
Okay, faster deployment is a clear win. What about afterwards? The long-term costs?
That's the other major benefit.
Yeah.
Maintenance cost reduction. Think about the old way. If an external service changed its interface, maybe a database schema update or an API move, developers might have had to manually update code in dozens of different places.
Yeah, that sounds like a nightmare.
It was. Tedious, error-prone, expensive. With MCP, if a service interface changes, you just publish the new schema document. The MCP-aware models just adapt because they understand the standard.
So you update one definition, not dozens of code snippets.
Exactly. It drastically cuts ongoing maintenance overhead. That agility that reduced cost is absolutely critical for making these complex AI systems sustainable and evolvable long-term.
Incredibly impactful for the bottom line then. Faster, cheaper. It sounds like it solves a lot of current problems. What about looking ahead? How does MCP help future-proof AI systems and help them scale as AI gets even more capable?
Yeah, this is where MCP really shows its strength in terms of built-in scalability and flexibility. It offers things that used to be really complex.
Yeah.
One key feature is hot plugging.
Hot plugging, like adding hardware to a running computer.
Pretty much the same idea for AI capabilities. Imagine being able to add a completely new data source, or a new analysis module, or even a whole new specialized AI model to your system with zero downtime.
Seriously, no interruption.
Correct. Because models find and use tools via their schemas, you can deploy a new capability, a new database, a new image recognizer, and the existing AI agents can start using it immediately. No retraining, no recompiling, no reconfiguration needed. It provides incredible agility. Systems can evolve and adopt the latest tech without skipping a beat.
That level of agility is amazing. What else helps with scaling?
Another powerful concept is hierarchical routing. In complex AI systems, you often have different models, each good at a specific thing. Right?
Yeah, like one for summaries, one for translation, one for math.
Exactly. An orchestrator, think of it as a master AI agent, can use MCP to intelligently route each specific task to the ideal specialist model for that job.
Okay, sending the job to the right expert.
Right. And this isn't just about getting the best result. It's also about managing resources smartly. Large models have limited context windows, basically, how much they can keep in mind at once.
Like short-term memory.
Kind of. If you overload it, performance drops. By routing subtasks to smaller, specialized models via MCP, you avoid cluttering up the big, expensive main model with irrelevant info.
Ah, so it saves context window space.
Yes, and it also significantly reduces inference costs. You're only paying to run the most appropriate, often smaller and cheaper model for each subtask, instead of running the giant power-hungry model for everything. It's much more efficient and cost-effective.
That makes so much sense for managing big, complex AI systems, a really clever way to optimize. MCP sounds incredibly elegant, but
Right.
Is this just a cool idea a few tech giants are playing with, or is it actually catching on widely?
That's what's really interesting here. It's rapidly becoming a de facto standard. We're seeing growing ecosystem support right across the AI landscape. It's not just one company's thing. Look at the major players. OpenAI's function calling, Microsoft's semantic kernel skills, Anthropic's tool use.
I'd heard of those, yeah.
While the names differ slightly, the core idea is the same. A structured, standard way for models to find and use external functions and data. This convergence among the big players is a really strong signal that this is the way forward.
So the industry leaders are aligning. What about the broader community?
That's the other piece. Lots of popular open source agent frameworks, the building blocks many developers use, are also adopting these MCP-compatible patterns. So you have both the commercial giants and the open source world moving in the same direction. It indicates a fundamental shift. This is becoming the standard expected way for AI agents to work and integrate. It's not just a trend, it's the new baseline.
That's really significant buy-in.
Absolutely, and there's a fantastic analogy from the lead architect of the LangGraph project that captures its potential. They said MCP does for intelligent agents what HTTP did for the web. It abstracts away transport details so creators can focus on higher-level capability.
Wow. MCP is like HTTP for AI agents.
Think about it. HTTP connected isolated computers and created the web, letting information flow. MCP is doing something similar for AI, connecting isolated intelligences, allowing them to collaborate and interact with the world effectively.
That's a profound analogy. It really hits home how transformative MCP is. It's the essential plumbing, the standard that lets AI become truly integrated, powerful, useful tools, not just isolated curiosities. That's why it's so important for you, the listener, to grasp this. Okay, so we have Evals building trust, making AI reliable and responsible. And we have MCP enabling utility, letting AI connect and interact seamlessly. But you hinted they're not separate things. They work together, right?
Okay.
How does that synergy play out?
You're spot on. They absolutely reinforce each other, creating this powerful synergy that enables what we call responsible scaling of AI. Think about it. As we develop and deploy these bigger, more powerful multimodal models, ones that handle text, images, audio, the potential for unexpected risks naturally goes up. That's where rigorous EVI gears are just non-negotiable. They give leaders, decision makers, a quantified, objective look at the residual risk. It's not guesswork anymore. They have hard data on accuracy, fairness across groups, safety boundaries. This data is essential for making informed choices about where and how to use these powerful AIs responsibly.
So evals give you the risk assessment. Where does MCP fit into that responsible scaling?
MCP provides the operating guardrails. Because MCP dictates that models can only call vetted, pre-approved tools whose risks and functions are understood, it inherently limits what the AI can do. It can't just connect to anything, only the secured, defined tools. Plus, every action an MCP-enabled model takes every tool call, every data access gets logged in a standard way. This makes auditing after deployment much easier and more thorough. You have clear traceability.
Okay, so evals quantify the risk, and MCP provides the controlled, traceable environment for the AI to operate within those risk boundaries.
Exactly. You know the risks, and you build the system to manage them proactively, even as you scale up complexity.
That's fascinating, knowing the risks, managing them systematically, but does this focus on safety and control, this layered approach, does it maybe slow down innovation, that rapid progress we expect from AI?
It might seem counterintuitive, but actually, it enables faster innovation with accountability. It's not speed versus safety. It's a synergy that can actually accelerate progress responsibly.
How so? Faster because of the safety measures.
Yes. Think about evals giving you early signals. Before sinking huge resources into a new AI idea, teams can use evals to quickly check for potential risks. If an early eval flags a safety issue, maybe a new architecture hallucinates too much or shows bias, you can redirect efforts before making costly mistakes.
Preventing wasted effort on dead ends or dangerous paths.
Precisely. It makes the whole R&D process much more efficient long-term. And then, once an idea looks promising and safe, MCP reduces the engineering friction of actually trying it out in a live setting. Because MCP standardizes interactions, plugging a new research prototype or experimental feature into an existing system becomes much, much simpler. Less custom integration, less patching APIs. You're leveraging established protocols.
So it's easier to experiment responsibly.
Exactly. Responsible exploration actually speeds up because deployment and integration are easier. The combined effect is a more agile, more confident, and ultimately faster development cycle for AI that you can trust.
That's a really powerful framing, safety and structure enabling speed. It sounds like this combination has really broad implications everywhere. Can you give us a couple more concrete examples to help listeners picture this?
Sure. Let's take healthcare again. Imagine an MCP-enabled clinical assistant AI. via MCP. It securely pulls specific patient records from the hospital's EHR system respecting privacy rules like IP, because the EHR connection is defined and secured through MCP. Then, it might invoke a specialized dosing calculator tool, again via MCP, using the patient's data to get an accurate dose. And crucially, MCP ensures the AI documents its steps. Retrieved record X, invoked calculator Y, result Z. It creates a transparent, auditable trail. Clinicians can see exactly what it did and why.
Okay, so MCP handles the secure connections and actions. Where do evals come in?
The evals are running constantly in the background. They rigorously certify that assistant's diagnostic accuracy across different demographics, making sure it's fair and doesn't perpetuate bias. They test its robustness. Can it handle messy, incomplete data? How does it react in emergencies? So you get an AI that's super useful and integrated, thanks to MCP, but also rigorously verified for safety, fairness, and reliability, thanks to evals. That builds the trust needed for high-stakes use.
That's a great healthcare example. What about another field, like finance?
Okay, finance. Think about AI for automated trading or risk assessment. Regulatory stress tests, which are basically very complex evals run constantly, maybe nightly. These evals simulate extreme market crashes, sudden economic shifts, things like that. Now imagine an automated trading AI. If a nightly eval detects a problem, maybe its risk prediction goes haywire, or its performance drops unexpectedly, it triggers an immediate failsafe.
And MCP handles the failsafe.
Yes, the eval detali issue. And that immediately halts the relevant MCP workflow. The MCP protocol stops the potentially faulty AI from sending any more trades to the market.
Preventing potentially huge losses or market disruption.
Exactly. It's a critical circuit breaker. It prevents harm, ensures stability, keeps automated systems within safe boundaries. Again, it's the combination. Evals for detection, MCP for controlled action and prevention. Incredible agility, but with rigorous, continuous risk management baked in.
What's particularly compelling here and really fascinating is how evals and MCP create this virtuous cycle. It's not just about building slightly better AI. It's about building trusted and useful AI that can genuinely change industries, improve lives, but doing it safely, managing risk, and maybe even speeding things up. It's a really elegant framework. So as we wrap up this deep dive, it's really clear, isn't it? The future of AI isn't just about bigger models and more data, as our source material highlights. That's only part of the story now.
Indeed. The whole community, researchers, industry, regulators, they all recognize there are two equally critical commitments needed now. First, measure everything that matters. That means going way beyond just accuracy. We need to measure factuality, fairness, robustness, privacy, efficiency, all those dimensions we talked about. Evals are the tools that give us the evidence, the proof that builds real public trust. Without that measurable evidence, fear and uncertainty will always hold AI back.
Measure everything that matters. Got it. What's the second commitment?
Second, connect intelligence responsibly. That's where MCP comes in. It provides the universal plumbing, the standard framework that turns powerful but isolated AI models into dependable, auditable systems that can actually integrate with the real world safely and effectively. It's how they go from being cool lab demos to being reliable parts of complex applications, interacting safely with data and tools.
The takeaway from the article seems crystal clear then. Organizations that really invest in both areas, deep evals, adopting MCP, they're the ones already shipping safer, more adaptable, better products. And the flip side is also clear. Neglecting either evals or MCP, that risks stalled innovation, or much worse, causing unforeseen harm, the kind of harm that could damage the entire field and destroy public confidence. So as you, our listener, think about everything we've discussed, maybe consider this final thought. The path for AI isn't just raw smarts. It's defined by trustworthiness and real-world utility. The imperative seems clear. Build comprehensive evals, adopt the model context protocol, let the next wave of AI flourish, but with confidence. So the question we leave you with is, what will you build with this newfound confidence, knowing these foundations are in place?